Hello and welcome back to module number 7. We are going to talk today about distribution analysis, and we are going to see about what is distribution, what is frequency distribution, what is the reference to descriptive statistics, and how it display variable one versus multiple variables. And then we're going to talk about how to generate histogram using open source R. And basically this is where I'm going to pound or re-emphasize the importance of R in today's visual analytics. There is no one person that doesn't talk about R as the main tool for them to create the visual analytics. So let's start with the basics. What is distribution? The idea of distribution is a statistical data set that is listing of functions showing all possible values in the data, and often with how much they occur with regard to frequency. So when a distribution of categorical data is organized, you can actually see what it's all about with regard to the number of percentage of individual in each group and so on. And a good example of that was in the last election, when they broke down the population who voted for Trump, who voted for Clinton, with regard to the age, regarded to the race, example to the education, etc., etc. So this is a distribution, the idea of how I distributed the data in a data set. The dimensions of distribution in visual display is basically consists of three things: shape, location, and spread. So the shape is the shape show how the variance is distributed about the location. The location is about the expected value out of the outcome being measured, and the spread is the expected amount of variance associated with the output. So basically the spread is the expected amount. And basically the graphical most often used to display the spread is the plot box and histogram. So the spread and comparison, the spread usually allowed us to show systematically the peak about how the distribution possibly break down with regard to, is it to the left, to the right, to the peak, or double peak, or multiple peaks. And by doing that, allowed us to see how the distribution is being displayed. And so one of the things that we often look at, and again, this is the two idea of the spread, but one of the things that we often talk about with regard to the distribution is the location. And the location is the value, a value around which the process is being stabilized, which is where we are talking about, if you remember, the mean and the median, and how it is being displayed with regard to the overall performance. So the location is best displayed by, again, box plot and histogram, and also scatter plot. Scatter plot is really powerful when you have multiple variables in the location. Example of scatter plot, and again, this is GPD per capita and life expectancy, and again look at how it is displayed in this plot and how it been distributed. The shape is also about how the variance is distributed about the location. So it tells us about the systematic, about the mean, and possibly about the multimodal that it consists of. So in the shape, we have to talk about the systematic, the shape, and the uninformed. All of that create or generate our understanding of the shape of the distribution. So again, this is the outline, and to the right, to the left, or the uninformed. And again, this is giving us some ideas how the distribution is being shaped with regard to visualization. I did not talk yet about box plot, and again, this is an excellent tool for or display for converting the location and in particular illustrating the location and the changes between the two groups over time or over the machine or over other characters. So this is a good display of the box plot, and it's really often used with regard to that. Another way to talk about distribution is to talk about frequency distribution, and the table that organize data value into classes or intervals, and we have a formula for that. We are talking about frequency. So we are talking about ungroup and group frequency, and all of that is part of how our discussion, how our terminology with regard to distribution. So ungroup, we have the frequency courses take, and then when we have group, we're talking about the age of voters and the frequencies. Again, look at the difference, see the difference, and see how it play out. So when we are talking about ungroup frequency distribution, again, we see that there's a lot of shape and bake going on here with regard to the distribution. It's not one part or one element. It usually consists of more than one. So the group of frequency distribution, usually we are displaying it in histogram, and the idea of the histogram is that the x-axis is the data value and the y is the frequency. So the bar graph that represents frequency distribution, and usually we have a scale that will allow us to identify the set that we want to display. So again, frequency distribution, per pod frequency and the f, and this is how we set it up in order for us to display it. The relative distribution and the relative frequency distribution is about adding the percentage into the distribution to provide more transparency or more accuracy to the data that we are trying to display. And when we are talking about relative frequency, we are talking about class frequency divided by the sample size. So the idea here is the relative frequency histogram allowed us to display something that is usually more accurate or more precise in the eye of the outsider. So the idea here is that we have percentage, and the idea here that we are usually summarize it in percentage. So again, the histogram is a perfect tool for that. Percentage wise is on the x-axis, and on the x-axis is the level of smokers, and by doing that we are able to display that and able to communicate the result. When we are talking about group frequencies, we usually display it in groups, and the idea of the groups is how those groups score in the exam and how frequency they score that. So in this case, we have in group frequency distribution, we have lower class, upper class, and class with regard to the difference between the lower and the lower class and the higher class. And by doing that, we are usually using basic statistics with regard to class midpoint and class boundaries in order for us to do to calculate and to provide some indication to the value of it. So we can construct a frequency distribution. We have some procedure that we often use, and by doing that, we are able to do central tendency distribution. We are able to measure the tendency based on the mode, the median, and the mean, And by doing that is something that we already discussed, which is part of descriptive statistics. So the mode is the score that occurs most frequency in the data set. Example, the scores in the first exam, and this is a great example of it, that the majority of the students got the score between 86 to 87, and by doing that we are able to to do that. But we have also a problem with two peaks, which means that the distribution has two modes, and it's usually called binomial. And by doing that, score 1, and look at what we have here. We have the people who score 75 to 80, 86 to 90, almost 90, and then 90 to 95. So we have more than two peaks in this example with regard to the scores. And even though the lowercase was not displayed or not was emphasized, the binomial distribution look only on the peak side of it, which is the score of the 86 and the score of 94, which was the peak in overall performance on the distribution. The distribution, we are talking about the distribution that occur more than 2 times. And so in this example, if we will scale a little bit or highlight the values a little bit better, we will see that the scores in the 3 groups that we combine the data, the 75 to 80, the 80 to 85, and the 90 to 95, we have multiplied out the distribution with regard to the value. So when do we use the mode? As I said before, and in the beginning, with regard to descriptive statistic, mode is not useful to measure the central tendency. So it has incentive to large changes in the data set. That is, 2 data sets that are very different from each other can have the same mode, which does not help us much, and that's why the mode is not usually used in descriptive statistics. Based to my favorite of all time infographics about cakes and data visualization of the bakery, and again, it is great visualization, but what do you get out of it? What do you remember out of it? And this is something that we always need to remember. You try to show something that is meaningful to us, something that is important. And again, is that visualization capture that importance. When we're looking at the highlight, the 23% and the 25%, this is where it's supposed to be shiny. And in this example, some of you complain that it is not very transparent, which I totally agree. So, and histogram, we always show the center, we show the distribution, we saw the modality, we also look at outsider or outliner, and by doing that we are trying to capture the variety of the data set in order for us to do better, to be more transparent with regard to our visualization. The issue with the histogram is that for a small set, histogram can be misleading. Small change in the data can be deceived, and by doing that we might deceive the viewer from outside, something that we are trying to avoid at all times. For a larger set, histogram can be quite efficient to illustrate the distribution. But again, the same complaint about small set of data that can be misleading, the same problem can appear also in larger set where the distribution does not show extreme or outsider values that might be in the distribution. So the issue is, again, you have to be very careful with the axis and the scale in order for you to display that. And we will learn slowly but surely, we will learn how to do that in open source R or R Studio, and how to do that. And then again, this is a very powerful tool, because it not only shows us the distribution, it also shows us the curve of the distribution, that again, it is something of the data. And we have the issue of, when we are talking about histogram, we are talking about density estimate. And again, the idea here is that, can we predict or can we calculate the distribution based on estimate? And by doing that, again, this is the power of statistics come into play with regard to what is the center point, how can we predict or implement that into our analysis in order for us to show distribution. So again, you can show what is the value of it and how to apply that, and I'll teach you how to do that in R, because again, Excel or SPSS or any other application out there does not do such a good job with regard to display exactly where the values are. So it's the right time to start talking about the introduction to R and R Studio. What is R? It is a software package for statistical and graphical. It has a collection of more than, this was in 2015, there was almost 6,700 packages. Today we are talking about, the latest release was about 18,000 packages that people created and we are allowed to use for our own usage. We do not need to pay for it. So it is a programming language. So you will encounter, for the first time, you will counter the idea, what is it the programming language add to the R in order for it to be produced. It is a working environment. So you will need to set up yourself that you're going to work. It's not going to set yourself up in a browser and then close it up and start the next day with another application. No, this is a work in progress. You're going to create several files in order for you to set up the environment that you will be able to work. And one of the things that it's really interesting about the R is that it is more than, I believe they said, the last example that they said is 17 million people around the world use R on a daily basis, which is quite a lot, and it is very powerful. And one of the things that I'm sure that most of you like, it is free to use. You do not have to pay for it. And so this is the number of packages, and this is in the scale that they did from 2002 to 2014. And as the popularity grow, it probably will go beyond that. So a little bit of history has to be told here. R was developing in Bell Lab in 1970s. But during that time, Bell Lab did not continue the development of S because they had a lot of issue, and it was sold to private companies that did not think beyond the money idea. So in 1990s, two professors from New Zealand came up with the idea of taking the code of R and convert it into open source environment. The names are Ross Ikana and Robert Gentleman, and both of them still alive, still kicking and enjoying the R, but they said in the New York Times article that they came up with the idea of R because both their first name started with R. So the idea was that this is how they're going to call it. The R is based on S. So the code is basically written in C++. but it has some modification that you will, again, for those people who are not programmers, do not panic. Everything will be under control. You will be given the code, so you will have a better understanding what does it entail. So S was largely used to make good graphics, but it was not an easy thing to do, and it was the idea that came up that was later on. For example, of the S programming language, again, this is something that I would like you to see and how they apply it and what do they do. So a few examples, one of the leading packages in R, and that is already, when you download RStudio, already embedded into the R, is the ggplot2. And the ggplot2 is the ideas that you can manipulate the data with multiple colors, with a lot of added values that usually you don't get in any other platform. And the idea here is, again, my mistake. This is the homepage of ggplot2. We will talk about ggplot2 quite a lot. But one of the things that they do quite well is to give you reference to all the elements of the plot or how you're going to generate of it. And they do that by breaking down each component. And I will talk more about that. I will talk about the grammar that we are trying to implement into our visualization in order for us to communicate better, in order for us to do better, in order for us to apply that. So this is an old example of the R without the ggplot2, but basically black and white examples. And the idea, who is using it, how to do that, I'll give you more videos on the subject. And again, one of the things that I want you to see the importance of it. The job market nowadays asks that you will have at least skills in ggplot2 or in open source R. So it's really important that you will know that, even though I'm going to give you a hard time on how to apply the ggplot2, I want you to have at least sense that this is where the market is, this is where companies are looking for, and this is an example of my work. And again, this is something that is really important because, again, trying to take a large data set and convert it to more meaningful or more understanding of what it is part of what I will try to do. So the RStudio is basically a window environment, and basically it's an easy way to use the R instead of writing the code in a terminal. So it is also free, and it's allowed us to apply a lot of things. This is the basic screenshot of the R. The R has a code as the terminal that runs the code. We have a history. We have the plot that we are be able to open it, and we have packages. When you are looking at the RStudio, this is the code. Example, in this case, I use a data set that I created. So I run the code, I run how I want to display it, and I will say a normal distribution. I set up some premises to my analysis, and then the code that goes here, it says I want you to run to the R in order for you to display. Again, I will talk about what is aesthetic, what is the inspiration of aesthetics in this class, and how it comes about when the creator of ggplot came with this idea and why he thought about that, and how to apply the aesthetics in order for us to display something like that. So this is part of what we will learn in R and how to do that. But RStudio did not stop on that. It also applied a lot of application. The RStudio also have something that they called Shiny, which is an open application for the browser. So you can write your code on the browser and run the data set that hosted by the RStudio and generate your visualization. An example for that was the New York Times during the election used the RStudio in order for them to display and to apply. I highly recommend you to visit RStudio and see what it is entail, because it has a lot of things that is really important, and we will learn about those things. Shiny, I just want to show you just a short example of the power of Shiny. I'm going to click on See Gallery, and again, we talked about example of the Google set and how to do that. And again, it allowed us to multiply, to do what to do with that, how to apply that. And this is again based on a map, based on Google Map, based on data that we are doing, and able us to do what is the best way to find it. And this is a very powerful tool that I want you to be involved or to be aware of. Maybe that's something that you want to do. The basic graphic in R consists of plot, bar plot, histogram, and pie, which is probably what all the software application that we looked at. And when we are starting with basic in R, usually we have to create a container that holds data. So in this case, 40, 30, 20, and 10 is what I call my data. And I call it my pie. And my pie basically tell me that I can generate a simple graph of a pie by using this code. But if I want to become a little bit more fancier, and I use the word fancier, if I want to add red, blue, green, and black, and again, I define that as another line in my code, which I call my colors, and I defined what colors they, and then write the code pie, my pie, and column my code. That's what will happen. The same goes with bar chart. Again, the same container, the same data set that we started. And so in the case, he will display me a simple bar chart without any visualization, without any colors. So again, I can add names with regard to colors, and we can say heat, and he will display me the colors. And I can also make it a simple histogram. And again, I'm using a data set called empty cars, and I'm going to display empty cars with regard to the frequency. And I'm using one variable out of this data set called my cars. So if you look at a data set called my cars, no, sorry, it's not my cars, it's empty cars. Sorry, I always get confused because in the past I used to have this data set. So if you look at my cars, it's a data set. So you can see that they collected MPG, they collected all those components on the cars. Usually it's on old cars, but those are the components that we are trying to capture, and trying to capture that in visualization. And again, I can break it down into histogram. I can do that, apply that, and see what it is. I can add normal curve, like we learn about that, and this is the code where I said set it up the code, and I'll give you more explanation in my canvas page about this code and how to apply that. And so this is the normal curve of this type of data. Bar plots, it's again the same thing about negative and opposite. And again, I can apply time series and apply that in R. And again, the issue is that we can do that with a lot of possible scales in order for us to be more accurate, more transparent with regard to the data. One of the most highly referred terms now in research is called spatial data. And usually it comes from data on Earth, on oceans, on things that we are often forget about when we are talking about data. And usually it's about a large set of data, that example, earthquake in the ocean, and this is a big problem. So again, we are able to do that in R quite easily, and I will teach you, I will go through that. And again, this is just an introduction to introduce you to one of the most powerful visual analytic tools that if you are in that position that you want to have this field, you have to know R in order for you to do that. When we are talking about two variables, we can do that. We can apply scatter plots into it and apply what it is stand for and how to do that. And we can learn that maybe there is no relationship in that plot by using the visual aspect of the data, or if there is a relationship, maybe it's a linear relationship, which means that one affect the other. So all those components, all those aspects can be displayed quite nicely in open source R and especially in ggplot2. I will have a special session with regard to ggplot2. So again, this is something that we often use about scatter plots and when we have a lot of data set, and this is something very powerful. When we have the tool that allowed us to display a large amount of data and to do that aesthetically, that is pleasant to all people, not only to the teacher, but to your peers in the class, to your mentors, to your friends, and so on. This is something that we will learn how to do and how to do that in R. And again, I talked about two variables versus one variables and how to apply that. Again, I will give you the codes, I will give you more reference to it, and you started to read about R and with that regard and how to apply that. And when we have multiple variables, and again, this is the power of R when we are talking about how to capture that. So multiple variables, more than two variables, we can do that and we can do it quite easy. How many dimensions represent here? Again, this is something that is really nice. All voters, white, blacks, Hispanic, and other nationalities can be displayed. Again, this is the power of R. This is what I want you to do. One of the things that we also will learn about is network analysis. What is network analysis? Is to try to figure out, example, who are the people who are exposed to Twitter, and especially Trump tweets. And you will see that people try to analyze it with regard to network. Who are the network that follow Trump and who are they represent? And so we will see that, we will see what it entails and how to apply that and how to discuss it and visualize it. And one of the things that is often missing is the idea of the 3D, and again, something that our textbook often criticize us not to use the 3D because it can be misleading. And again, one of the things that we lose control, we lose understanding what it is we are trying to represent, and something that I want you to start to comprehend and start to apply that when you are thinking and you are trying to visualize it. What can we do and how can we reduce the confusion with regard to the direction and what is being done? I want also you to watch this video of Hans Röhling. Hans Röhling was a researcher for Sweden, and what he learned, what he studied was the idea of population and wealth. And so he came up with BBC and generated a very nice visualization of the wealth of the universe with regard to people earning money and what they do with that and how to apply that. So this is really visualization that done right, and see how beautiful it is. So best practices. I always need to remind myself about best practices. Keep in mind when you write your blog, think about best practices. So keep interval consistent. Select the best interval using measurements that are resistant to the outliers. Keep interval the size of it, the categorical, and must be equal. Show example from the book, and based on the book we have top histogram is one with consistently sized age interval. The second histogram gives the end of 20 years of age group, but 10 years in the middle. So all those examples show you what is being done and how they try to capture that with regard to visualization and what is it consist of. Learn about what is interval consistent. Why is it important? So selecting the best interval to represent your data, again, this is really important, and this is something that I want you to take into account when you are starting to analyze not one variable but multiple variables into it and how to apply that. That's all for this module. If you have any question, let me know. This was introduction to distribution. I talked about open source R. I introduced to you. I will give you more reference to it. Again, this is the beginning. This is the open mode to what we are going to experience from now on with regard to open source R and visual analytics. Until next time, I hope you're good, and please let me know if you have any questions. Until next time, have fun.